All right, this anchor application is called a high-strength tie-off or tensionless wrap. This is the strongest anchor that we can utilize utilizing rope because it involves an unloaded knot. As soon as we load a knot that is within the rope system, that immediately decreases the overall efficiency and load capacity of that rope. So when we do the high-strength tie-off and tensionless wrap, we're typically applying those when we have applications in the rope environment that are going to produce tremendous forces, high lines, descending high lines, operations along those lines. The reason we don't often use it for our more simplistic applications is because there's some downsides to implementing it. The first one being we have to take the end of the rope or the rope bag itself and we have to wrap it progressively around the anchor. It's ideal to put some edge protection on the anchor so that the rope itself does not encounter any burrs or any obstructions on the anchor itself that could cause damage to the rope when it's loaded. Once that edge padding is in place and we start our wraps, there's a little bit of a guessing game involved. So there's not a firm science or a firm application that I can give you that says you're going to do exactly this number of wraps to incorporate enough friction within those coils or wraps so that the knot is not loaded. The actual application that I can give you is that you are going to wrap that anchor enough times that when you do produce load on the tension line of the rope, you have a slack segment between the knot and the lowest coil. That number of coils is going to increase as the diameter of the anchor decreases. So the smaller the diameter of the anchor, the more coils or wraps we're going to have in place. The greater the diameter of the anchor, the less coils or wraps we're going to have in place. So let's begin. In this application, we're going to start with the bight and the carabiner. We're going to come up to our anchor and we're going to wrap the anchor. We want to make sure that we keep our coils straight, clean, and neat, and we keep them staggered so that they're in close proximity to one another. Using edge padding such as this on an anchor like this is appropriate even though we're getting nylon on nylon production, because a high-strength tie-off or tensionless wrap, although it can generate a tremendous amount of heat fusion or heat friction because of load, the rope is not moving across this anchor. So we're not going to generate a lot of friction or heat production in the rope system because of movement. It's just going to be potentially because of load. Once we think we have the appropriate number of wraps around that anchor, we're going to go ahead and make our connection point with our carabiner. Ensure that on these anchor components that you're using an appropriate design load hardware or carabiner in this application. We want to encourage you to always use G-rated gear at your anchor points. Once those coils are in place and you've made your connection, you also want to ensure that this connection point is assembled so that this line or the tension point of the rope is running directly to the load. Don't put any directional pull on this by short setting it. So make sure that you've got enough slack built into that back leg that this rope can naturally lie where the load is going to take it. Once it's in position, you tension that lower line. As you tension that lower line, you'll see your coils start to compress. You should get movement in your coils closest to the tension line, and you should have no movement in your coils furthest away from the tensioned line. Once it's fully pressurized and tensioned, as long as it has not drawn this bight of rope or this figure 8 on a bight with a carabiner back down towards the coils and tensioned it, you've put an appropriate number of wraps into that system. High strength tie-off or tensionless wrap.